Hey everyone, and welcome back. We're diving into the world of LLMs today.
Large language models.
Yeah, you got it. Those AI systems like
ChatGPT
ChatGPT.
that can write poems or translate languages, even code.
Yeah, it's really incredible stuff. But what if they could do even more? What if they could actually learn and apply rules just like we do?
That's a great question.
Yeah, that's exactly what we'll be looking at today.
It's a fascinating area of research. We often hear about LLMs and how they generate this human-like text,
Yeah,
but their ability to reason logically, that's always been kind of a challenge.
right. It's like they can talk the talk, but they struggle when it comes to walking the walk,
Yeah,
especially when it comes to tasks that require like specific knowledge.
exactly. Yeah. Think of it this way. You're trying to solve a puzzle, but you don't know the rules of the game.
Okay,
You might be able to move the pieces around,
right.
but you won't be able to solve it effectively.
And that's where this research paper we're looking at comes in. It really highlights how LLMs often stumble with logical reasoning.
They do.
In fact, incorrect rule generation by these models was responsible for a lot of errors, like 65% on one relational reasoning task,
Huge.
and even more on a numerical reasoning task, 81%.
Wow, those numbers are really telling. It shows that it's not enough for LLMs to just sound intelligent.
Yeah,
They need to be able to think systematically
for sure.
and apply rules consistently.
So then how do we bridge this gap? How do we teach these LLMs to actually think more logically?
Well, that's where the hypotheses-to-theories framework comes in.
Okay, hypotheses-to-theories, HTT.
HTT, yeah.
Tell me more about that.
So HTT is this two-stage process that's designed to help LLMs learn rules almost like we do.
Interesting.
The first stage is what's called induction.
Induction.
So imagine teaching a child about colors.
Okay.
You might show them several red objects and say red.
Right.
And eventually they start to associate that word red with the color red,
Yeah.
and they can then identify red objects on their own. Induction is similar to that.
Okay.
The LLM is presented with training examples and tries to generate potential rules from these examples.
So instead of like programming these rules into the system,
Yeah.
it's learning them through examples.
Exactly. Just like a child learning through observation.
That's amazing. It's like we're teaching them to think for themselves.
Yeah.
So what happens after that induction stage?
So then the second stage is called deduction.
Okay.
And that's where the LLM puts those learned rules to the test.
Uh-huh.
It uses them to solve new problems
Right.
by retrieving the right rule from its internal library to arrive at a solution.
So it's kind of like they've built a mental toolbox during induction,
Yeah.
and then they know which tool to use for which task during deduction.
That's a great way to put it. If we think about this on a larger scale, you can see how HTT offers a pathway to developing these AI systems that are less prone to making those errors we talked about earlier.
So by learning rules, these LLMs become more reliable,
Yeah, more reliable.
more predictable, and ultimately more trustworthy.
Exactly. And it really does open up a world of possibilities.
It does. But before we get into that, I want to see some concrete examples of this.
Of HTT.
Yeah.
Sure. The paper showcased it in action for several types of reasoning.
Cool.
Let's start with relational reasoning,
Okay.
using a task called CLUTTR. This involves understanding complex family connections.
Okay, so like figuring out how people are related in a huge family tree.
Exactly. Imagine the LLM learns the rule, brother's daughter is a niece.
Okay.
And now it's presented with this complex family tree and needs to figure out how two individuals are related.
Right.
And it can use its rule, navigate those connections, arrive at the correct answer, even if the relationship is several steps removed.
That's really cool. So instead of like memorizing every possible connection, it can actually deduce the relationship based on these rules.
Exactly.
That's impressive.
And this approach isn't limited to just family trees.
Okay.
The researchers also tested HTT on numerical reasoning tasks, specifically base 16 arithmetic.
Base 16 arithmetic, I'm not familiar with that. Can you
Okay.
break that down for me?
Yeah, so you're probably familiar with our usual base 10 system,
Uh-huh.
where we use digits from 0 to 9.
Right.
Well, base 16 uses digits from 0 to 9, and then letters A to F to represent values from 10 to 15.
Oh, wow. So it's like a whole new language of numbers?
Exactly.
Yeah.
And HTT enabled the LLM to learn the rules of addition in this system,
Oh, wow.
just like it learned the rules of kinship for the family tree task.
So it's not just about memorizing these facts and patterns.
Right.
It's about learning the underlying logic of the system
Yeah.
and then applying that to solve new problems.
Exactly.
The researchers didn't stop there, though, right?
No, they also explored how HTT could be used for something called concept learning.
Okay.
They used a data set called list functions,
Okay.
which involved the LLM figuring out how to transform lists based on rules.
Interesting. What kind of rules are we talking here?
Well, some of them were pretty complex.
Yep.
Like one rule was to identify the most frequent item in a list, even if the items are presented in random order.
Wow.
Another was to sort the list based on a specific criterion.
That's pretty advanced. So the LLM is going beyond pattern matching and understanding the concept behind it.
Exactly. And what's really fascinating is that even GPT-4 was able to discover and apply these rules.
That's incredible. It really shows the potential of HTT to push the boundaries of what LLMs can do.
Yeah.
But what does all this mean for us in the real world? Why should we care about LLMs learning rules?
That's a great question, and one we'll explore further in the next part of our deep dive.
All right, listeners, stay tuned. We'll be back to discuss the real-world impact of HTT and what it could mean for the future of AI.
So we've seen how HTT allows these LLMs to really grasp and apply rules, moving beyond just pattern recognition.
Yeah, it's really interesting stuff.
But now I think it's time to explore why this matters, why this development has the potential to really change the way we interact with AI.
Yeah, what kind of real-world applications are we talking about?
Well, think about those really dense legal documents that we often encounter.
Yeah.
Contracts or terms of service, even legal rulings.
Right.
All can be incredibly difficult for the average person to understand.
Oh, yeah, for sure.
So imagine an AI that could not only summarize these documents,
Yeah,
but also explain those underlying legal principles in plain English,
that would be amazing.
ensuring fairness and transparency for everyone involved.
It'd be like having your own personal legal translator,
Yeah.
breaking down all that complex jargon.
Yeah, and the applications go way beyond just the legal field.
Oh, really?
Think about complex tasks in healthcare, like diagnosing diseases.
Okay.
An AI powered by HTT could analyze patient data, medical research, and establish diagnostic criteria
Wow.
to arrive at a more accurate and nuanced diagnosis.
So it's not just about, like, crunching numbers.
Yeah.
It's about understanding the reasoning behind it all.
Exactly. And let's not forget about education.
Okay.
Imagine AI tutors that can personalize learning in real time,
That would be incredible.
adapting to each student's needs and learning style.
Yep.
They could identify a student's strengths and weaknesses and tailor lessons and exercises to address those specific areas.
It's like having a tutor that understands not just what you're struggling with, but why you're struggling with it.
Exactly.
That could really revolutionize education.
Yeah, it's pretty exciting stuff, but we also need to be mindful of the limitations of this approach.
Right. It's not a magic solution.
Yeah, HTT is not a magic solution.
Okay.
It faces certain challenges,
Okay.
especially when we're dealing with LLMs that haven't been trained on a vast and diverse data set.
Right, because if the training data is limited, then its mental toolbox of rules might be incomplete,
Yeah, exactly.
making it harder to solve certain problems.
And even with a well-stocked toolbox, there's the issue of the LLM's memory capacity.
Okay.
The size of its rule library is limited by how much information it can hold.
So even if it could theoretically learn all these rules,
Yeah,
there's a practical limit to how many it can use at any given time.
that's right. And this raises a really important question for future research.
What's that?
How do we scale up this approach? How do we teach LLMs to learn and apply increasingly complex sets of rules without running into those memory limitations?
Yeah, that's a good question. Are there any other limitations to consider?
Well, one that comes to mind is the challenge of teaching LLMs to learn rules for tasks that are more nuanced, less clearly defined.
Like what?
Well, how do we teach an LLM to understand humor or irony,
Oh, yeah.
which often rely on subtle cues,
Right.
cultural contexts, even personal experiences?
That seems like a really difficult task.
It is. And it highlights the fact that even with all these incredible advances in AI,
Yeah.
there are still vast areas of human cognition that we just don't fully understand ourselves.
It's true. We're still trying to figure out our own minds.
Exactly, which makes teaching AI to do the same all the more challenging.
This has been a really interesting deep dive.
It has.
We've explored how LLMs can learn rules and the potential real-world impact,
Yeah.
and even talked about the philosophical implications of AI that can reason ethically.
Yeah, some really big questions.
I'm sure our listeners are going to want to learn even more.
I hope so.
So before we go, be sure to check out the show notes for links to the research paper and other resources.
And as you delve deeper into the world of LLMs and rule learning,
Yeah.
here's something to think about. We've seen how HTT can help these AI systems learn rules from human knowledge.
Right.
Our legal systems, our ethical frameworks, or mathematical principles.
Yeah.
But could this approach be turned inward?
What do you mean?
Could it help us unlock a deeper understanding of our own minds? Could it shed light on the mysteries of human thought, creativity, even consciousness itself?
That's a great question.
It is.
And it really is a reminder that trying to understand AI is ultimately trying to understand ourselves.
Yeah, and that's what makes this field so fascinating.
It is. All right, until next time, keep exploring, keep learning, and keep diving deep.
What's really captivating is the glimpse it offers into a future where AI isn't just a tool,
Yeah.
but a partner, a collaborator that can really help us navigate the complexities of the world.
Yeah, and we've touched on some practical applications like legal analysis or diagnoses, but it sounds like the potential goes even deeper.
It really does, yeah.
What else is there?
Imagine AI systems that can help us grapple with ethical dilemmas,
Okay.
not by telling us right answers, but by illuminating the different perspectives,
Okay.
the potential outcomes, and the inherent trade-offs.
So instead of just like giving us information, it's more about helping us understand all the nuances.
Exactly. Think about it. You're facing a difficult choice with no easy answers.
Yeah.
An AI equipped with HTT could access vast stores of ethical frameworks, historical precedents,
Wow.
even philosophical arguments,
Okay.
to help you weigh the options and make a more informed decision.
It wouldn't tell you what to do, but it would give you more information to help you decide.
Exactly. It's not about replacing human judgment.
Right.
It's about augmenting it,
Gotcha.
giving us a wider lens to view these complex situations.
This has been a really insightful deep dive.
It has.
We've explored how LLMs can learn these rules,
Yeah.
the real-world impact, and even the philosophical implication.
Big question.
It's a lot to think about, and I'm sure our listeners will want to learn more. So before we wrap up, be sure to check out the show notes for links to the research and other resources.
Definitely. And as you all delve deeper into this world,
Yeah.
I want to leave you with one final thought.
Okay.
We've seen how HTT can help AI learn rules from human knowledge, our legal systems, our ethics, even math.
Yeah.
But could this approach be turned inward?
What do you mean?
Could it help us unlock a deeper understanding of our own minds? Could it help us understand thought, creativity, even consciousness?
That's a really fascinating question to think about.
It is.
And it really emphasizes that to understand AI,
Yeah.
we need to understand ourselves.
It all comes back to that.
It really does. And that is what makes this so fascinating.
It is.
All right, that's it for today. Until next time, keep exploring, keep learning, and keep diving deep.